Hi Year 9, today we're looking at exercise 1206, which is talking about the sine and the cosine ratio. So what you are to complete is question 1 ABC, question 2 ACE, question 3 all, question 4 all, and question 5 all. So what I'm going to do is I'm going to go through some of these questions with you. So for question 1, it says find sine theta and cos theta in these triangles as a simple fraction. So I'm going to do A and then you'll be able to do B and C on your own. So what we want to do is look at what our sine ratio is. So our sine ratio is sine theta equals our opposite over our hypotenuse, and then our cos ratio is our adjacent over our hypotenuse. So what we want to do is we want to highlight our angle and then label our triangle. So our hypotenuse is the side opposite our right angle. Our opposite side is opposite our angle, and our adjacent side is next to our angle. So then for sine theta, what we have is sine theta equals O over H, and we want to substitute in our values of O and H. So sine theta equals our opposite side, we were told is 3, and our hypotenuse is 5 in the way that we labelled our triangle. Then for our cos ratio, we have cos theta equals A over H, and in our triangle we are told that our adjacent side is worth 4 and our hypotenuse is worth 5. So that means that cos theta equals 4 over 5. Moving on to question 2, we want to find the unknown side using Pythagoras' theorem and then find sine theta and cos theta in decimal form correct to 3 decimal places. So I'm going to do question 2, B and F. You were to do A, C and E here. So for question 2, B, we have our triangle, and what we're asked to do is use Pythagoras' theorem to find the unknown side. So our unknown side, our hypotenuse, and our triangle, which is this side here, and I'm going to call that X. So we are finding X. So when we look at our triangle for Pythagoras' theorem, our C side is our hypotenuse, so our side opposite our right angle, and then we have our A and our B to be our other sides of our triangle, our shorter sides of our triangle. Remember, our hypotenuse is always the longest side. So then what we're going to do is we are going to use C squared equals A squared plus B squared, which is Pythagoras' theorem, and we're going to substitute our values from our triangle into this theorem. So our C value we have called X, so we'll have X squared equals A, which is 6 squared, plus B squared, which is 3 squared. So then X squared equals 6 squared is 36, plus 3 squared is 9. So we'll have X squared equals 36 plus 9, which is 45. Now we want to find the value of X. So what we have to do is we have to take the square root of both sides. So the square root of X squared is just X, and the square root of 45 we're going to leave as root 45. So then what I'm going to do is I'm just going to actually pick up this C. I'm going to move it over here, and I'm going to write next to my X that it equals root 45. Now, we've done the first part of this question. So we have done finding the unknown side using Pythagoras' theorem. That is what we have done here. Now, the second part of our question says to find sine theta and then find cos theta in the decimal form. Correct to 3 decimal places is the key bit there. So what we need to do in order to find sine theta and cos theta is we need to label our triangle. So our hypotenuse is opposite our right angle, so that will be our root 45. Our angle that we have been given, I need to highlight. So our angle is our theta here. And so our opposite our angle is our 3. And adjacent to our angle is our 6. So now that we know this, we need to write out our sine ratio. So sine theta equals O over H. So our opposite side we have been told is 3, and our hypotenuse is our root 45. Then we are asked to find sine theta, and we want decimal. So we just go 3 over root 45, and when we do that we get 0.447 2135955, And we were asked to round this to correct to 3 decimal places. So that means that we want 3 numbers after our decimal point. However, that 4th number determines whether we round up or not. So because that 4th number is a 2, we do not round up. So that means that sine theta will just equal 0.447. Then we want to do the exact same with cos. So we have cos theta equals our ratio A over H. So then we want to substitute in our cos into our adjacent side and our hypotenuse into cos theta. So we'll have cos theta equals our adjacent side, which was 6, and our hypotenuse, which is root 45. So we then are going to put that into our calculator. So we'll get cos theta equals 6 over root 45, which equals 0.894427191, which will equal to 3 decimal places. So 1, 2, 3. That 4th number after our decimal place is less than 5. So our answer will just be 0.894. Moving on to F, we need to find the length of the short side. So I'm going to call that y this time, and I'm going to label my triangle in relation to Pythagoras' theorem. So with Pythagoras' theorem, C is always my hypotenuse, which is my longer side, and then I have my A and my B. So what we're actually trying to find here is we're trying to find the shorter side. So the Pythagoras' theorem that we use is that we move the B to the other side of our equation by minusing B squared. So because we're trying to find A, so we have A by itself. So we'll use A squared equals C squared minus B squared as our formula for this. So A squared equals C squared minus B squared. So then we're going to substitute in our values. So our A is y, so y squared equals C squared, which is 6 squared, minus B squared, which is 4 squared. So we have y squared equals 6 squared is 36, minus 4 squared is 16. 36 minus 16 is 20, so we have y squared equals 20. And then we're going to take the square root of both sides to get y equals the square root of 20. So again, I'm going to pick up that C and just move it over to the side. Oh no, not the C. Sorry. Let's undo that. Oh, I'm going to pick up the A and move it to this side and write on my triangle that y equals root 20. So then we want to label our triangle because we want to find our sine theta and our cosine theta ratios in correct to 3 decimal places. So our hypotenuse is our 6. We want to look at what our angle is, and we have that our angle is there. So our opposite, our angle is length 4, and then adjacent to our angle is our root 20, which we just calculated. So we have sine theta equals O over H as our trig ratio. So sine theta equals O, which is 4 over our H of 6. So then we'll just have that sine theta equals 4 over 6 into our calculator is 0.66666 all the way to 7. And so to 3 decimal places is here. The 4th number after our decimal place is greater than 5. So it will round that last 6 up to be a 7. So that means that sine theta will equal 0.667. We then want to find cos theta. So cos theta is A over H. So we'll have cos theta equals our adjacent side of our root 20 over our hypotenuse of 6. So cos theta equals, we put root 20 over 6 into our calculator, and we get 0.74559,925, and so to 3 decimal places. So we just want 745, and that 4th number after our decimal place is a 3, which is less than 5, so we don't round up, so it's just 0.745. Now looking at question 3, we want to use our calculator to find the value of the following correct to 4 decimal places. So I'm going to do B, F, and G for you. All you have to do in your calculator is press the ratio, so in this case cos, and then put in your number. So I will just, in my calculator, go cos, it will bring up a bracket, 30, close the bracket, equal, and we get our value for this of it equal to 0.8660254038. And again, we're asked to round to 4 decimal places this time. So 1, 2, 3, 4. And that number after our decimal place, after our 4th decimal place, the 5th number is less than 5. So we don't round up. So our answer will just be 0.8660. For cos 85 in our calculator, we go cos bracket 85, close our bracket, equals. So cos 85, close our bracket, equals, and we'll get 0.08715574275. Again, we're asked here to round to 4 decimal places, so 1, 2, 3, 4. That number, that 5th number after our decimal place is a 5, so it means we round that 1 up by 1. So our answer will be 0.0872. And lucky last, we have cos 50 degrees 20 minutes. Now, I didn't realize that I picked all cos questions for this. You do the exact same with sine. You just press the sine button. In fact, I will change this and do K just so that I can show you that it's exactly the same. So for K, we have sine 40 degrees 7 minutes. So in our calculator, what we do is we go sine bracket, we go 40, and then because we have degrees and minutes, what we have to do is we have to press our degrees minute second button, our 7, and then our degrees minutes second button after that as well. So that is the button that we have to press. We then close our bracket and hit equal. So when we put that into our calculator, so sine excuse me, 40 degrees minute second, 7 degrees minute second, close our bracket, equal, we get 0.644346191. Again, to 4 decimal places, so we have 1, 2, 3, 4. That last number, the 5th number after our 4th decimal place is a 4, so we don't round up. So our answer will just be 0.6443. For question 4, it says, what happens to sine A as A increases from 0 degrees to 90 degrees? So what I want you to do here is to draw a table up. So I want you to draw a table up for both A and B, as it will show you what happens. So I want you to have your values. So you can just pick a couple of values. So you'll have your A here and then sine A. So let's start with 0 degrees and let's just go up by, let's say 10, 20, 30, 40, 50, 60, 70, 80, 90. That should be enough. So then just go 10 degrees, 20 degrees, 30, 40, 50, 60, 70, 80, 90. So you don't need that last one. And what you need to do on your calculator is just go sine 10 equals, for example. So sine 10 equals, and write your decimal, I would say, to 3 decimal places, or just 2 decimal places even. So 0.17, and then do the same for sine, say sine 50. Put it in, you'll get 0.77, and do it all the way up, and then write in words what happens as sine A to sine A as A increases. Then do the exact same for cos A. So you could have, instead of having that there, you could just continue your table on. Obviously like an actual table, and have the exact same